All right, guys, so we're going to talk about inverse proportions. So we talked about direct proportions, where you set something up as a fraction, miles of A over and hours of A on top, miles of B and hours of B on bottom, right? So it's miles over miles, hours over hours, and it's quantity 1 over quantity 2, quantity 1 over quantity 2. For an inverse proportion, you're going to set up this same equation, and you're going to flip one side. I always just flip the right-hand side. So here goes. Let's take a simple one. On a bike, the front sprocket has 48 teeth, and it is spinning 120 RPM. The back sprocket has 12 teeth. How fast is it spinning? Okay, so here we go. We're going to take this thing, and we're going to take teeth on the left and speed on the right. Now, a direct proportion would look like this. You would say the front sprocket has 48 teeth, and the back sprocket has 12 teeth. And so your proportion is front over back. And then you go to your other unit RPMs, and you would put front over back. Okay? That would be a direct proportion. So when you're turning a direct proportion like this into an inverse proportion, all you're going to do is take this original equation and flip one side. So you're going to end up with 48 over 12 equals x over 120. Now to solve this equation, the easy way to solve it, just like direct proportions, is you're going to cross multiply. So you get 12x equals 48 times 120. So that's 12x equals 5,760. Divide both sides by 12, and you get x equals 480. And since the top of this fraction was RPM, since the 120 was RPM, so you get teeth over teeth, RPM over RPM, so x will be in RPM. And in general, what you need to know is that with chains, belts, and gears, we typically have an inverse relationship between the size of the item that's spinning and the RPM. So for an example, you went from more teeth to less teeth. The number of teeth went down. That means the speed will go up. It will go in the opposite direction. So if the number of teeth go down, the speed goes up. If the number of teeth go up, the speed goes down. Okay? So here we go. We have a small gear, has 14 teeth, and is spinning 6,000 RPMs. So again, if you were going to do this as a direct proportion, and I always like to make sure you know if you're going to do it as a direct proportion, you set it up one way. If you're going to do it as inverse proportion, you'll set it up as a direct and then flip it. So as a direct proportion, here's what we're going to do. You've got a 14-tooth gear and a 144-tooth gear, so you say 14 over 144. And I want you to think it's small over large. So on this side, it's going to be small over large. So small over large. This would be a direct proportion. You're going to come over here, and the inverse proportion is going to be the exact same equation, except you take this side and flip it. So it's going to be 14 over 144, right? Small over large equals large over small. Okay? And again, what I want you to see, a direct proportion is when one thing goes up, the other one goes up. An inverse proportion is when one quantity goes up, the other one goes down. So here the number of teeth went up, the speed has to go down. Okay? So if we cross multiply this, we get 144x equals 14 times 6,000, which is 84,000. We're going to divide that by 144, and you get x equals 500 and 83.3 RPM. Okay, 583.3 RPM. And again, what happened? The number of teeth went up, the speed should go down, and it did. So that makes sense to me. That is an inverse proportion. So now, sometimes we get a thing called a compound gear train. This is an example of a compound gear train. And this is where we want to do this same thing we did in the previous problem, but we want to do it multiple times. We want to do it multiple times in a very small space. And so here's what we've got. We've got a driver. This is the original gear. This is the one that's hooked to a motor or something that's making it spin. It has 8 teeth. It is going to connect to this large gear here, which has 24 teeth. So this, whatever speed this is spinning, this is going to spin slower. Now, this gear and this gear are on the same shaft. That means whatever speed this gear is spinning the same speed. And then this gear is going to turn this gear, and again, you're going from a little gear to a big gear. The number of teeth increase, so the speed is going to decrease. Okay? So here we go. They've given us that gear A, this is gear A, and it's turning 1,000 RPM. They've given us that. Okay? They want us to find the speed of gear B, the speed of gear C, and then the speed of gear D. Okay? We've been given the number of teeth. Okay? The number of teeth. So we're going to make this work here. So here goes. We're going to do the math. Make a little room with my paper here. All right, so what do we got? We're going to set up an inverse proportion. So we're going to set teeth over teeth. So if I do A over B, okay, the direct proportion will be A over B. So it'd be teeth over teeth, right? So I'm going to say 8 teeth over 24 teeth equals, now, if this was a direct proportion, it would be the speed of A over the speed of B. But since it's an inverse proportion, one side's A over B, the other side's going to flip and be B over A. So that's going to be X over, and gear A was spinning 1,000 RPM. Cross multiply this, you get 24X equals 8,000. And if I divide both sides by 24, I get 333.3 RPM. Now that is the speed of gear B. That's gear B. Okay. Now gear B and gear C are on the same shaft. So what that means is gear C is spinning 333.3 RPM. Okay. So now I take gear C. Gear C has 8 teeth. So I say C over D. So I'm going to say 8 over 24 equals, and a direct proportion would be C over D equals C over D. But an inverse proportion is going to be C over D equals, and then you're going to flip it and put D over C. So speed of D is unknown. Speed of C is 333.3 RPM. And you get 24X equals, well, let's take that number times 8. And I get 2666.7. And if I divide that by 24, I get X equals 111.1 RPM. So gear D is spinning 111 RPM. Okay? Gear D is spinning 111 RPM. So that is an application for inverse proportions. Keep an eye out for the next video. Appreciate you watching, guys.